on the slight level. Okay, so what we've done so far is we've done permutations, we've done fundamental counting principle, basically, and we've done words and things without repetition. Even when we did cars and we were lining up cars, they looked different. Even if we had to start with a black and end with a red car, they all looked different, correct? Well, today's the day where that changes. We can now use the word Canada because it has more than one A. You know, it's going to be fun. You're welcome. All right, so we have a bookstore. Get ready. Is advertising signed copies of books about 3 famous Canadian hockey players in the Hockey Hall of Fame: Wayne Gretzky, Patrick Waugh, and Steve Yzerman. The books are arranged on a vertical display stand. Wow, right? So on this vertical display stand, if you're arranging something, you're giving it a what? An order. And if you don't believe me, there are people's jobs to figure out where they should lay stuff in on shelving units in grocery stores for you to better see them to buy the stuff. So they'll put like lower, crappy, yucky stuff that kids would like. They put it lower so that kids' eyes are attracted to it, because kids not going to look at the top shelf. And then they put the middle stuff and then the less important stuff on the top shelf. People spend their lives doing this. So if you don't think arranging matters, talk to those people who it's their job. It totally matters. Their jobs be gone. So we're arranging them. The moment we are arranging them, we are giving it an order. It's a permutation. All right? All right. Okay. I know I'm cool. You're welcome. The books are arranged on a vertical display shelf. One possible arrangement is shown below. Wow. Right? So we have a little Gretzky, a little Waugh, a little Yzerman. Coolness. I know. So his name is not Roy, just so you know. It's Patrick Waugh. Please don't call him Roy. That's weird. Okay, he would not like that. How many different arrangements are there? Okay, so let's list some. We got Gretzky, we got Waugh, we got Yzerman. We could keep Gretzky up here. Then what could we do? Yzerman and the Waugh. Then what could we do? What's up? What are you going to comment? Oh, son. That makes sense. I couldn't figure out who was missing, and I just skipped him. Here you go, son.
He's my son.
I know. Okay. So we could have a Waugh, an Yzerman, and a Gretzky. We could have a Waugh, a Gretzky, and an Yzerman. We could have an Yzerman, a Gretzky, and a Waugh. We could have a Yzerman, a Waugh, and a Gretzky. Yeah?
Great.
I start out with Gretzky's, flip the other two. Start out with Waugh's, the other two. Start out with Yzerman's, did the other two. Okay? How many different ways could we arrange these books on a shelf? 6 ways. How could we do this without listing all these, knowing our knowledge? 3 factorial, because we'd have like 1 blank here, 1 blank here, 1 blank here, correct? And how many books could be on this spot? 3, and then we'd leave 1, then 2, and then we'd leave 1, and then 1, and 3 times 2 times 1 is 6. So we could have used the fundamental counting principle to do it. Yep. This was a column. I just didn't relist it.
But it's the same as one that you did. Right?
No, this is Waugh, Yzerman, this is Yzerman, Waugh. Yeah. So we could have used our good old 6 ways, right? 3, 2, 1. Didn't have to list them all. Fantastic. But it's going to get crazy. Get ready. Stuff is going to get crazy. The bookstore, not the bookstore. I don't know what that is. The bookstore sells out of autographed Wayne Gretzky books. What is going to happen? I don't know. Let's keep reading. I'm on the edge of my seat here. I'm not sitting. I'm on the edge of my board here. Okay. Book including the display copy. The sales clerk replaces the Wayne Gretzky book with what? What? A second. Roy. What? Roy. I just said Roy. Waugh book. Oh my gosh, he would be totally disappointed with me. One possible arrangement is shown. Sketch all the possible arrangements of the 3 books. How many arrangements are there? I know. Let's figure this out. This is going to get crazy. Okay, so I'm going to swap these books, and I'm going to go Eiserman, and I have a totally different look. Right? I have a totally different, they look totally different, so different, like 100% different. Like I walked up and I'm like, yes, you changed them. Yes, you did. Totally. Mm-hmm. Does it look like I changed them? Please stop me. Okay, no, it doesn't. This and this, they be the same, right? They look the same. You like turn around and you turn back and you're like, you did nothing. That's what you would say to me. If I put them in the exact same spots, obviously. And the copies look the exact same and they weren't like different looking, right? Okay, what is another way I could do? I could go Eiserman, wah, and then I could go Eiserman and flip the wah-wahs. Wah-wahs. Wah-wah. Now they look totally different. No, they don't. Okay, so this technically is one case. We agree? This technically is one case. We agree? Okay, then we could go wah, Eiserman, wah, and I'm going to flip the wahs. So wah, Eiserman, wah. That sounds so much the same because it's the same. Okay, boom. So how many cases do we actually have of different looking things? 3. Now that would really not be fun if I had like a whole bunch of books and I had to try and list them, and then I'd have to take out the ones where they look the same, or the word Canada, and I swap the A's, and then you close your eyes and I swap the A's and you're like, it's the same word. That would be crappy if we had to like figure out how many doubled up, right? That would not be efficient use of our time, would it? No. So the best way to do these is to actually do your fundamental counting principle like you did before. Treat the books like they actually are all different, okay? Are they different? No. But how many books do we have? 3. So we would do it just like normal. We always, when there's doubling and tripling ups, we treat them like they're all totally different. So how many options of books would I have for the first? Then, now to fix the problem, to get rid of all the cases where they actually do look the same, you just divide by however many there are the same factorial. So how many are the same? 2. So we're going to divide by 2 factorial, which is 6 divided by 2, which is 3. That's all we have to do. We're going to treat the questions exactly the same as we've done them, but we just have to divide by the factorials of doublings up and triplings up. Okay? So for example, if I had 4 slots for books, right? And I had a wah, Eiserman. Those are the 4 slots I have. Obviously, if I flip the R's and the Y's right now, I have the same situation, right? It would look the exact same, wouldn't it? Yeah. So we're going to have cases where it's the same. So what do? We treat it like they're all different. How many books do we have to put in row? 1, 2, 3, 4. How many options do I have for this blank? 4. Then. Okay. That would be the answer if they actually were all different. For example, if it was a wah and an Eiserman and they were different types of books, right? They weren't the exact same looking book, but they do look the same. So I have to divide by 2 factorial for the R's and 2 factorial for the Y's. Why can't I just divide by 4? Because there's 4 items that are kind of the same. 2 factorial times 2 factorial is 4, and 4 factorial is 24. If I divide by 4 and I divide by 24, do I get the same answer? No. So you have to divide by, if there's 2 R's and 2 Y's, 2 R's, 2 Y's. Now, type it into your calculator and get an answer. Every single one of you has to try it out. I want to tell you what the real answer is. You're just going to try it out and see what you get. You should get an answer of 6. Some people will not. Okay, if you're typing it into your calculator at once, if you go like this, 4 factorial divided by 2 factorial, 2 factorial, your calculator does order of operations. It is trained to do order of operations. That is what it will always do. So it will go 4 factorial divided by 2 factorial, which is actually 12. And then it'll take your answer and it'll times it by 2 and get you 24. So if you got 24, it's because you didn't put this bottom in brackets. It will always do order of operations. So if you want something done first, if you put it in brackets into your calculator, it will do it first. Because your calculator does order of operations. So if you put a bracket around anything, it immediately has to do that first. Because your calculator is BEDMAS. It does brackets, exponents, division, multiplication, addition, subtraction. So you have to make sure you do this. Now, if you have the fancy calculators, one second, I gotta get mine up. So everyone's gonna try this with me. If you have the new calculators, if you don't have the, if you have the TID3s, don't waste your time. If you have the TID4s, the other ones, you're gonna try it with me. Now, up until now, if you've had to put in a fraction, you always have to put fractions in brackets so your calculator knows it's a fraction, right? Why? Because it does BEDMAS first. So it's gonna do this bracket, 1 divided by 2 bracket. So it's gonna treat it like it's a fraction, it's gonna do it together. Yes? Now, the one that I told you to put in, I told you, don't do this, but I told you if you go like this, oops, forgot I'm on this calculator. Oh, my other calculator doesn't, I don't have to go twice. Ah, Savannah, why is this going so bad? That's recorded. Oops, you're welcome. Ah, the anger level is rising. I feel like Alex right now. Okay, 4 divided by 2, math, over, 4, 2, math. I would never do this because 2 factorial is 2, but I'm going to do this because you will. If I do it like this, I get 24, which is wrong, right? So I told you, and the TID3s, you're always going to have to do this anyways. You're going to go, I'm going to steal that because I'm not typing it twice. Little instance, did you know there's an insert button on your calculator? So you don't have to retype stuff? Okay. So I can go over here at this spot, and I can go second, delete, and I can insert a bracket. And then I can, yeah, that's not even the life lesson that you're learning here, but I love that you guys are super excited about this. So you can insert a bracket. That isn't the exciting part, actually. That was just, you should know that, but maybe you don't. So the exciting part is, if you have the other calculators, you won't need brackets for fractions, because there's a button that will make it look like a fraction for you. And you should use this for life if you have this button. You should be super appreciative that you have it, and don't be like, I'm not going to remember how to do that. No, you are. You are going to. If you have this fraction button, it is going to be your friend. And when you see a fraction, you're going to type it in like that, because then it will actually just look like what it's supposed to look like. Okay? Are we following along? TID3 people, just ignore me and don't be sad. I'm sorry. You don't have this button. So we're going to go. Ready? Are we ready? And you're like, I'm never going to remember this. You will. You will. I promise. You will. Alpha. Y equals. And then you're going to pick this one. And it's going to pop up a fraction, guys. Watch this. Enter. Whoa. Boom. Shakalaka. Like, this is not, life is not getting better right now. Like, this is, you guys have reached your peak. This is where you're at. Okay. So we're going to go 4, math, boom, boom. And then we're going to go over 2, math. And then it just looks like what we typed, and we don't need brackets because my calculator knows it's a fraction because I made it know it's a fraction. And drop the mic. I don't need brackets. I know. Your life has just gotten 700 times better. Yeah, anytime you have a fraction, you should be typing that button. Yeah.
I broke my calculator.
Not sure how. Okay, life lessons. Everyone feels so much better about themselves except for the TID3 people. I apologize. You guys are wonderful. Your calculators are equally as beautiful. You know, your calculators don't suck at all. They are just as nice and pretty as the other ones. We will not bully your calculators. Okay. Flip over. Oh my goodness, what is happening? Oh, all the ways we can rearrange rows and not have to write them out. You're welcome. Okay, so we're looking at the word rows. Yes? And I told you to list out all the outcomes of the ways you could write rows. You're probably going to miss 1, 2, or 5. If I give you the word like Mitsubishi. And I made you rearrange. I just came up with that one. You're welcome. I just wanted a long word and Mitsubishi came to my head. Why is that the first word? That's what's going on in here. You guys really don't see what's in here and you should be very happy. Okay, so we rearrange Mitsubishi. You're probably going to miss one or a few hundred of the examples of Mitsubishi rearranged, right? So thank goodness I don't make you rearrange Mitsubishi. You're welcome. Okay, it's a gift to you. You say you don't get gifts, there's one. Okay, so we rearrange rows. We got rows, we got rows, we got Rousseau, we got Rousseau, we got Reus, we got Rousseau, Ors, or Ruse, or Sur. I'm going to stop. We have all the different rearrangements, yes? And so we have 4 times 1, 2, 3, 4, 5, 6. So we have 24 of those bad boys, yeah? You're like, Lepp, this is stupid. We could just go with 4 blanks. Yes, we can. We're going to do that. So we would be like, I'm not listing them. I have 4 blanks. How many letters do I have for the first one? 4. Then, right? Which is 4 factorial. We agree? Which is 24. Boom. I have my answers. But then I'm like, no rows. We're going to do Ross. Yes, we are. We're going to take a break. Minor, what would you call it? Commercial break. Ross instead of rows. What happens? What happens when we have Ross instead of rows? So many bad things. Ross and Ross, same thing, but I swapped the S's. Did you notice? No, you didn't, because it doesn't look any different. So we're going to treat it just like we did before. What are we going to do? This is where I told you we start stacking letters. So we're going to go R. Why did I run that one off the edge? I don't even know. Okay. We're going to go R, O, S, S. So I stack them for a reason. Yes, that is correct. It is Ross. So I stack them for a reason. I stack them twofold. 1, so I don't actually like miss a double up or a triple up. 2, I'm stacking them so my brain's going, why am I stacking these? Like, that's stupid. Oh, right, I need to divide by the factorials. Yeah, you're like, that. Well, I don't need that. Yes, you will. You will totally need that. So once you stack them, it often gives you a hint that, a little reminder that, right, yes, divide. Okay, so let's try it out. So we go 1, 2, 3, 4. We treat Ross like they're all different letters. So we get 4, then 3, then 2, then 1, and then we just have to divide by the 2 S's. So 2 factorial, which is actually 12. This is the easiest part. Don't stress out. You're okay. Alrighty. This just goes through rows, and then we have Rus, because Rus is a really good word we should work with. So what would we do with Rus? You just divide it by 3 factorial. So you get 4 factorial divided by 3 factorial, and there would just be 4 different words, which makes sense because I'd have R and then 3 S's, which is 1 word. I can move the R here and then have the S's. The R in the third blank have the S's. The R in the last blank have the S's. So I would technically only be able to get 4 letters from Rus. R, S, S, S. Yeah. Yes. So even though in these 4 examples, I switched all the S's, you can't tell, right? This is technically one case. So you would have to go through and find out all the cases where they looked exactly the same, which would be, and there's even more, which would be super unproductive, right? That would take forever and you're probably going to mess up. So instead of doing that, you treat them like they're different and divide by the factorial. Yes. Yes. Boom. Here we are. So this just sums it up. If you have permutations, the number of permutations of n objects where A are the same of one type, B are the same of another type, C are the same of the other, you're going to do n factorial. So you're just going to do all of the objects. So like we did 4 factorial because there was 4 objects, right? And then you divide by the tripling ups and doubling ups below. So we're going to look at Vancouver. Awesome. So every single time you get a word from now on, you will rewrite the word out. Yes. because we will decide if there's doubling or tripling letters. So we have V, A, N, C, O, U, V, E, R. And then we double, triple check to make sure we didn't like not double up or triple up where we were supposed to. Yeah. Now, how many letters are in Vancouver? This is true. So what are we going to have on the top? 9 factorial, or 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, because I would have 9 blanks, correct? And I'd have 9 options for the first blank, 8 options for the second blank, 7, 6, 5, 4, 3, 2, 1, which is just 9 factorial, right? And then if I gave this answer, it would 100% be on the diploma and wrong. Because what do I have to do? Divide it by 2 factorial. Now, I could do this, and I'm going to get it right because I divided by just 1 factorial, right? But if I have the calculator that lets me do the fraction, I should never choose to do this option. I should always go alpha y equals, enter, 9, because this takes away the error of the human, which is you. Just so you know. Some people are like, my calculator doesn't work. And I'm like, it's you. It's the operator. Your calculator will always do bedmass rules. So if you don't force it to do it in the correct order, it will do it bedmass-wise. So if I had, for example, 9 factorial divided by 2 factorial, 2 factorial, it's not going to do brackets because there are no brackets. It's going to do division and multiplication in the order in which it happens, right? That's what bedmass does. So it's going to go 9 factorial divided by 2 factorial, take that answer, hit enter, and then multiply by 2 factorial. That's what your calculator will do. It does bedmass. Brackets, exponents, division, multiplication in order, addition, subtraction in order. So if you want something to happen, you need to bracket it. Or use the fraction button if you have it, because it should be your BFF. Okay? So second alpha, sorry, it should not second alpha. Alpha y equals, enter. Do mathematical and go. M-A-T-H, ooh, this is my word. M-A-T-I-C-A-L. How many letters are in mathematical? 12. For those of you who put 11 and 13, please make sure you double up and triple up count. On the bottom, we get 2 factorial, 3 factorial, 2 factorial. If you have the older calculators, you're using brackets. If you have the newer calculators, you should be using the fraction button. And if you're not, and you make a mistake, and you get the answer, that because you forgot the brackets on a cumulative, because you're like, I got the brackets now. Yeah, but when the cumulative comes, ooh, the brackets, they fall off. And then you get it wrong, and then you bring it up to me. I'm just going to put a sad face. I do this sometimes with tears and a puddle for my tears that are crying as you didn't put the brackets, because you revolted against my fraction button.
I will remember to put brackets.
We will see. If you get the, this is not my first rodeo, Elix. I am going to put like a sad face with tears and a puddle. And I'm going to put it in blue highlighter, so it's very noticeable. We will see. Sure. With yellow highlighter. You want to see what it looks like? It looks like this.
I thought that you only used commas in numbers in the United States. My mom's going on. He's vaping.
That is not vaping. So, Brett bought a carton containing, this is getting riveting again, edge of the seat material here, guys. 10 mini boxes of cereal. Wow. I used to love the little mini box. No, like the little mini boxes, you know? Oh. Yeah, you can even make your own bowl out of them. Did you know that? Yes, that is part of it. Yes, did you not know the mini box cereal can be made into their own little bowl? Why do you even buy them if that is not the case? No. No, okay, are we listening? Okay, we're listening. You open up the side of the box. There's even a little perforated thing to open the side of the box. No joke. This is real. And then you take the little bag, and the little bag splits up the middle. Did you not notice this? And the little bag sits in the box because you don't have a cardboard box as your cereal box, because that would be gross and melty and a little grossy. You have plastic in cardboard. It can't get much better than that. So then you open it up, and then you pour the milk in there, and then boom, you've got yourself a cereal bowl. Now you're all going to go want to buy some to try it out. You try it out. It's real. 1983, circa 1983, 1993, 2003, and 2020. Okay. There are 3 boxes of cornflakes. Can we tell the difference between those boxes? One has not been stepped on or something weird. 2 boxes of Rice Krispies, 1 box Cocoa Puffs, 1 box of Shreddies, and the remainder are Raisin Bran, which used to be my favorite cereal. How many Raisin Bran are there? 3, 4, 5, 6, 7, 3. There's 10 in total. There's 3, 4, 5, 6, 7 used up already, so there's 3 Raisin Bran. Shh. I know, thank you. Over a 10, because they wanted you to do some math, because you're in math. Oh. Over a 10-day period, that is not a riddle. Over a 10, it's the worst riddle ever if that's it. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning, because he is a rebel without a cause. He's eating 1 in each blank, right? Fundamental counts principle. How many different orders are if the first morning must be Raisin Bran? This is getting wild. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Guess what I do first? I don't even do the question first. I go like this, boom. And then on the bottom, I immediately put the doubling up and tripling up so I don't screw up and forget to put that. So I'm going to do 3 factorial, 2 factorial. Could I technically go 1 factorial, 1 factorial, 3 factorial? Could I list them all with factorials? Sure, 1 factorial is 1, does nothing. But you could.
You're just explaining it for people who don't understand.
Chill, Elix. Okay. So the first day has to have how many boxes of choice? 3. Some people will say 1. Remember, you're treating them like they're all different and then dividing them off at the bottom, right? So I have to treat it like I have 3 Raisin Bran boxes, although they look the same. Who cares? Now, how many Raisin Bran did I leave there? 1. So how many boxes do I have left? 9. 2 Raisin Bran, sure. That's true. Not where I was going. So we have 1 Raisin Bran box left here. Okay? Remember, I told you you have to treat them like they're totally different, right? So yes, all 3 look the same, but I have 3 to choose from, so I'm going to put a 3 here. Okay? Then I used 1 box of cereal up. I ate it out of the box with the bag because that's the best way to do it. And then I had 9 left, then 8, 7, 6, 5, 4, 3, 2, 1. I started with 3 because there are 3 Raisin Bran boxes. And this 3 factorial gets rid of all the cases where the 3 Raisin Bran boxes are actually the same. Okay, we start with Raisin Bran in this riddle. Okay, and we get what? 15,120 different choices.